images of 3I Atlas, a third ever interstellar object observed from Earth, currently racing through our solar system. Now, astronomers have...
The alerts are multiplying. What began as a routine tracking of a few near-Earth asteroids in September 2025 has rapidly escalated into an unprecedented event. The tally of objects passing within the moon's orbit doesn't just climb, it shatters records. And as astronomers scramble to log each new blip on their screens, a more profound anomaly accelerates on its path. Is the solar system stirring? Or is something even worse happening beyond what the scientists can see? Join us as we discuss new objects that keep multiplying as 3I/Atlas closes on Mars. At least 28 near-Earth objects, that's the number astronomers logged, passing inside the orbit of the moon in just 1 week of September 2025. More than triple the previous record for such close approaches. It wasn't a slow trickle either, it came like a flood. One after another, each flagged and logged almost as soon as it was spotted. Planetary scientists had to watch the sky open up with traffic no one expected. But many of these objects were tiny and around 8 to 10 meters in length. That was the normal size for objects that burn up harmlessly in the upper atmosphere. However, 2 of these objects stood out completely. One was asteroid 2025 FA22. It was estimated to measure up to 120 meters across. That's about the height of a city block. It passed at just over twice the distance to the moon, around 835,000 kilometers. That might sound far, but in space terms, it's uncomfortably close. However, just 3 days earlier, another rock, 2025 RJ2, cut even closer and slipped by at only 0.78 lunar distances and less than 300,000 kilometers. These 2 were reminders that Earth shares its neighborhood with objects that don't always announce themselves until they're already passing by. But the discoveries didn't stop there. Every few hours, new alerts kept coming in from observatories around the world. The alerts came especially from the Rubin Observatory in Chile, which is newly operational and equipped with its powerful wide-field camera. Another observatory that was added to the tally is Pan-STARRS. Located in Hawaii, its telescopes sweep the skies looking for even the faintest or fastest moving dot. There is also the Catalina Sky Survey in Arizona and the Atlas Network, which is spread between Hawaii and Chile. Data kept pouring in from automated telescopes that are processed by trained software. Together, they formed a detection web so sensitive that the swarm of September 2025 couldn't slip through unnoticed. And yet, the pace was startling even to the astronomers who built these systems. Instead of 1 or 2 notable close approaches in a week, they were watching dozens, logged almost back to back. Each new detection seemed to multiply the sense of urgency. What had started as a rare spike soon looked like a record-shattering cluster. That raises the question, was this an illusion of better technology, or was something truly unusual happening in space? On one side, the explanation is simple. Detection technology has leapt forward. The Rubin Observatory alone can scan the entire sky in just a few nights, capturing objects that older systems would have missed. The improved efficiency means we're finally seeing the small asteroids that have always been zipping past Earth. Statistically, the more we look, the more we find, and that makes sense. But even after correcting for those advances, the September swarm is still confusing. Population models suggest the odds of spotting more than 25 sublunar near-Earth objects in a single week are less than 1 in 1,500. That's supposed to be a once-in-decades event, not something that arrives out of nowhere. The cluster looked too dense to be only about new technology. So, the other theories come into play. Some scientists point to patterns where small bodies get pushed into similar paths by the gravitational pull of larger planets. If a group of rocks shared the same orbital rhythm, they could cross near Earth right after each other, creating the kind of swarm just seen. Other scientists wonder about a hidden breakup event farther out in the asteroid belt. Perhaps a parent body is cracking apart and sending fragments on intersecting courses. Those fragments could drift into Earth's neighborhood in waves, creating a temporary burst of activity that looks less random than usual. Then there are the unsettling speculations, the ones circulating outside the cautious language of academic journals. Social media is filled with graphs showing the September spike, with people calling it too much to be a coincidence. Some wondered if it was a warning from the cosmos to remind us that the sky is more dangerous than we think. While most scientists don't lean toward that view, the public reaction showed how quickly strange numbers can stir unease. In the end, what happened in September 2025 may be explained by both sides of the equation. Better technology revealed objects we never would have seen before, but the clustering of so many close passes still strains the models we rely on. What really matters is the multiplication effect, because when you multiply the number of close approaches, you multiply the risk that one of them doesn't miss. And in a planet's lifetime, that roll of the dice eventually lands on impact. Take asteroid 2025 FA22. At around 120 meters wide, it doesn't sound like much when compared to the size of Earth, but size doesn't tell the full story. At speeds of 18 kilometers per second, a body like that carries more energy than the largest nuclear bombs ever built. If it had entered Earth's atmosphere instead of slipping past, the results would have been catastrophic. Most asteroids of this size shatter in the atmosphere, creating a massive airburst. That's what happened over Chelyabinsk in 2013, when a 20-meter rock exploded with the power of several 100,000 tons of TNT. The shockwave shattered windows across 6 cities and injured over 1,500 people. But FA22 is even 6 times larger and would have delivered more than 20 times that energy. The explosion could have flattened entire neighborhoods, caved in roofs, and turned buildings into rubble. For those at ground zero, there would have been no time to react, just sudden fire and collapse. And that's only if FA22 were made of ordinary stony material. If instead it were an iron asteroid, it could have punched through the atmosphere without breaking apart. The impact would leave a crater hundreds of meters wide, with a fireball so bright it would be seen for hundreds of kilometers. Dust and debris would climb into the stratosphere, and if that impact happened near a populated area, the devastation would rival the worst disasters in history. Now imagine the same scenario happening over the ocean, where most impacts are statistically likely to occur. 2/3 of Earth's surface is water, so that's where the dice usually fall. An ocean strike by a rock like FA22 would trigger massive tsunamis, walls of water tens of meters high, racing toward coasts within hours. For low-lying islands or coastal cities, the flooding would be catastrophic. Entire neighborhoods could vanish under waves that arrived with little warning. This is why the field of planetary defense exists at all. After Chelyabinsk, governments realized the blind spots in our sky were too dangerous to ignore. Billions were invested in surveys and emergency response planning. When the asteroid Apophis was discovered in the year 2004, early models showed a chance of impact in 2029. For years, the public was concerned, but later, scientific calculations ruled out the danger and stated that it was going to be a close pass of about 32,000 kilometers from Earth. Still, that close pass will serve as a global rehearsal for what planetary defense looks like in practice. In fact, NASA's OSIRISAPEX spacecraft is already on its way to document that flyby. That's a mission designed to teach us how Earth's gravity can tug on an asteroid and change its orbit. A real-life version of those drills is the 2025 September Swarm. It is a stress test of the systems we've been building. Can our observatories catch small, fast-moving objects before they pass? And can governments interpret the warnings and prepare for the worst? Each detection is a reminder that humanity lives under a constant rain of celestial debris. Most of it is small, and most of it burns up before it reaches us. But the more often we see the dice rolled, the closer we come to the day when one doesn't bounce away harmlessly. And that's why the parallel mystery of the interstellar visitor arriving at the same time feels like more than a coincidence. While the swarm of local asteroids captured headlines, something stranger was happening farther out. The third confirmed interstellar visitor, after Oumuamua in 2017 and Borisov in 2019, 3I Atlas, was cutting across the solar system on a path toward Mars. And unlike the swarm, its strangeness wasn't about numbers, it was about chemistry. Comets from our solar system are usually dominated by water ice. When they near the sun, that ice turns to vapor, driving the bright tails that make them famous. But 3I/Atlas didn't follow the rules. Observations from the James Webb Space Telescope in August showed it was spewing carbon dioxide at rates nearly 20 times higher than its water vapor. This flipped the expected chemistry upside down. Then came the metals. High-resolution spectra showed strong signals of atomic nickel streaming from the comet's coma. In most solar system comets, nickel comes paired with iron, released by the same heating processes. But in 3I/Atlas, iron was missing, nickel without iron. A chemical imbalance so rare that it forced scientists to rethink how such objects form. The surprises didn't stop there. As it moved inward, the comet unleashed sudden and violent eruptions that doubled its brightness in less than 2 days. Its tail split into multiple strands, with jets of gas and dust arcing in different directions. Rotation studies suggested the nucleus was tumbling slowly, perhaps on a complex axis, making its activity harder to predict. Instead of a steady fading glow, 3I/Atlas was a volatile presence, rewriting itself with every outburst. And all of this happened at the same time. Earth was dealing with its record-breaking swarm of near-Earth objects. On one side, a multiplication of numbers. On the other hand, a multiplication of anomalies. For planetary defense experts, the coincidence raised unsettling questions. Was this just random timing, or a glimpse of a solar system entering a more active phase? By the end of September 2025, astronomers had logged more than 50 objects passing closer than the Moon. The numbers broke every chart and left researchers debating whether it was a fluke or a glimpse of a new era of discovery. At the same time, 3I/Atlas brightened and spilt its secrets across the spectrum, a messenger from beyond the solar system, arriving in the middle of the chaos. It may be a coincidence. The swarm may simply be the product of our eyes, and 3I/Atlas may be a rare traveler whose timing happened to overlap. But to dismiss the connection outright is to ignore what these events really showed. The sky isn't just a backdrop. It is alive and capable of multiplying its mysteries when we least expect it. For planetary defense, the lesson is simple but sobering. Models built on probability can be broken by a single cluster of near misses. Chemistry textbooks can be rewritten by a single comet from interstellar space. Preparedness must evolve not just for what we expect, but for what we can't. In the end, whether the multiplication was a coincidence or a cosmic rhythm matters less than the effect it had. For one brief, unsettling window, humanity looked up and saw not emptiness, but activity. It may not be the new normal, or it may be the first hint of one. Either way, September 2025 proved something undeniable. We are not bystanders in the solar system. We are participants in an active one, living on a planet that spins through lanes of traffic we are only beginning to chart. And when the numbers multiply, so does the urgency to prepare and to understand. Thanks for watching. While you are still here, click on the link on your screen to check out another of our videos. See you there.